Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear those. Friends, today's video is question number 2.61 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's check the question. If the position of electron is measured within an accuracy of plus minus 0.002 nanometer, calculate the uncertainty in the momentum of the electron. Suppose the momentum of the electron is h upon 4 pi into 0.05 nanometer. Is there any problem in defining this value? So let's start solving this question with the Heisenberg uncertainty principle. What is that? Heisenberg uncertainty principle. It says that del x into del p is equal to h upon 4 pi, where we can write del x is equal to uncertainty in the position of electron. Uncertainty in the position of the electron, and del p is equal to the uncertainty in the momentum of the electron. Uncertainty in the momentum of the electron. Fine. So in this way we can find here, first thing, the uncertainty in the momentum of the electron, that is del p. We need to find in the first part of the question. Its value should be h upon 4 pi into del x. So here h is a Planck's constant. Its value is 6.626 into 10 to the power minus 34 joule second, divided by, sorry, not 2, it's 4. I'm sorry. So it is divided by 4 into pi value is 3.14 into del x value which is given. It is the accuracy uncertainty in the position. So that is 0.002 into 10 to the power minus 9 meter. Here it is given in nanometer. Let me clear it. 0.002 nanometer, which we will turn for the sake of calculation. We need to put in meters. So it will be 0.002 into 10 to the power minus 9 meter, because 1 nanometer is equal to 10 to the power minus 9 meter. So we got this equation. From here we calculate and we will find the value 2.63 into 10 to the power minus 23. Now momentum unit is kilogram meter per second. So here we'll got the value of the momentum. Uncertainty in the momentum, we find it here. Now in the next part they gave the momentum, and then is there any problem in defining the value? So first, whatever is given, we'll find the momentum which is given. So the given momentum del p is equal to h upon 4 pi multiplied by 0.05 into 10 to the power minus 9. We will again put to change it into meter. So this is given. Let's find the value over here again. So from here we'll find del p is equal to 6.626 into 10 to the power minus 34 joule second, divided by 4 into 3.14 into Now 0.05 into 10 to the power minus 9. So from here again we'll do the calculation and we'll get the answer. After doing all the calculation, it is 1.055 into 10 to the power minus 24 kilogram meter per second. So this is the given value. Given value. So from when we compare the given value with the calculated value, we find that the difference is very small. So the given value, let's compare both the values of momentum. We find that the given value, which is 1.055 into 10 to the power minus 24, is smaller than the calculated value of uncertainty. So we cannot define the values in this case. So I will write compare both the values of momentum. We find that the given value, that is 1.5055 into 10 to the power minus 24 kg meter per second, is smaller than the uncertainty of the actual momentum, which is what we calculated here. It was 2.63 into 10 to the power minus 23 kg meter per second. So in this case we are not able to define the value, which the main question, last part of the question, we cannot define the value. And that's all for today in this question. This is our answer. First part we calculated, second part we need to calculate again and compare. And after comparing, we find that the given value is very smaller than the calculated value of uncertainty. So we are not able to define the values. So that's all for today in this video. Hope you guys like the video. Please like, share and subscribe. And if you have any doubts, do write in the comment section. I will come back to you to answer your queries. Till then, thank you.